This is Shantan Kumar, Assistant Professor, Department of Mathematics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today topic is functional dependence. Here, the functional dependence is nothing but it is related to the partial differential equation. And moreover, this is based upon the Jacobian function. In the previous classes, we discussed clearly what is the meaning of Jacobian. In the Jacobian, how to find the 2 by 2 variables, and again how to find the 3 by 3 variables. That means the 2 by 2 that is dependent with respect to the independent, and in the 3 by 3 is also that how to find the 3 by 3 that is a dependent with respect to independent, and what are the properties based upon the Jacobian we previously in the session completed. And continuation of the Jacobian. Now today we are going to discuss that is a functional dependence. Here the functional dependence is nothing but, if you are going to refer that related to this one, the terminology we already studied or we know that is a dependence. The dependence, when you are going to discuss the dependence, that is automatically in our mind, the reflecting it is a linearly dependence and also linearly independence. And based upon the definition related to here also the linearly independent or linearly dependent, that is a functional dependent and functionally independent. If you are going to refer that linearly independent is nothing but previous noted, that is the determinant which is not equal to 0. And linearly dependent is also the determinant value is equal to 0. And based upon that, here also the functional dependence and functional independence also, if the functional dependence is also the determinant value is equal to 0, the functional independent is also called as the determinant is not equal to 0. But here, by using the same the Jacobian, we are going to discuss the condition. Here also, for example, if you are going to the definition and also the property wise, here how to we discuss that how to find the functional dependence and functionally other related, that is independence condition. Okay, and here let us assume that u and v be two functions of x and v. Suppose their functions is connected with a relation, that is f of u comma v is equal to 0, where here f is a differentiable, then we say that u and v are the functionally dependent. We shall prove that the condition for the functional dependency is nothing but that is dou of u comma v by dou of x comma y is equal to 0. That means the dou of u comma v by dou of x comma y is equal to 0 is nothing but, in previous session we clearly discussed what is the meaning of dou of u comma v by dou of x comma y. That is nothing but, if it is a two variables, that is by using the determinant condition, it is a ux and also uy, and with the help of that v is also vx and vy is equal to 0. This is the meaning of the functional independence by using the Jacobian function. Here u comma v is nothing but that is a dependent variable, and x comma y is nothing but that is an independent variable. And again, coming to point, it is clearly the definition. Let us the two functions u and v are functionally dependent if they are the Jacobian, that is a dou of that is a u comma v by dou of x comma y are nothing but that is indirectly j of u comma v by j of x comma y. That is the meaning of, in the previous session we clearly discussed, that is based upon the Jacobian. And continuation of the Jacobian, that is a determinant process. If the determinant the value is equal to, that is a ux and uy and vx and vy is equal to 0, if you get the condition is called as functionally dependent. That is a mean. And similarly, if the Jacobian of u comma v is not equal to 0, for example, that means the data is not equal to 0, such type of the condition is called as functionally independent. And again, here just now I said there is a functionally dependence is nothing but linearly dependent, that is data is equal to 0. And the functionally independent is nothing but that is the meaning of the linearly independent of the vector. If you keep in our mind, that easy to identify or easy to remember the condition, what is the meaning of the functionally dependent as well as the functionally dependent condition. Next one, for example, if you go to discuss that if u is equal to that is x plus y by 1 is x into y, and v is equal to that is tan minus x plus tan minus y, then you need to find that what is the value of the dou of u comma v by that is dou of x comma y. Hence, we need to prove that u and v are functionally dependent. And if it is possible that functionally related, that is a dependent, then find the relation between the given function u and v is the condition. For example, here at the time of this one, we need to remember the condition of, with the help of the given function, what is the value of that according to functionally dependent. And functionally dependent is nothing but just now I said that is meaning of the determinant is equal to 0. Now we need to find out whether the condition is satisfied or not. First of all, according to the determinant, here the u comma v is a given function clearly. That is u is equal to x plus y by xy. And similarly, v is also that is tan inverse x plus tan inverse y. And with the help of that u and v, that is we need to find out what is ux, that is a dou u by x. Therefore, u is equal to x plus y by 1 minus xy, and dou u by dou x is equal to with the help of that u by v formula. Here clearly there is a 1 plus v square by 1 minus xy whole square. And similarly, u is equal to x plus y by 1 minus xy. And it is also that dou u by dou y is equal to clearly by using the u by v formula. Once again, it is that is 1 plus x square by 1 minus xy whole square. And similarly, v is equal to tan inverse x plus tan inverse y. When we are going to finding with respect to x as a partial, that is dou v by dou x, the derivative of tan inverse x is nothing but 1 by 1 plus x square. And dou u by dou y is also the derivative with respect to y as a partial, that is 1 by 1 plus y square. Therefore, which is obtained that clearly that is dou u by dou x and dou u by dou x and dou u by dou y. And after getting that clearly these are values, we are going to replace in the derivative of that is a determinant condition, that is ux is equal to 1 plus y square by 1 minus x whole square, and dou u by dou y is equal to we already completed 1 plus x square by 1 minus x whole square, and dou u by dou x is also 1 by 1 plus x square, and dou u by dou y is also 1 by 1 plus y square. And with the help of this one, that is finding that there is a 2 by 2 type process, that is AD minus BC. Therefore, AD minus BC is clearly obtained that AD is a 1 by 1 minus x whole square, minus BC is also 1 by 1 minus x whole square. Therefore, the both are the values are cancelled. Then you obtain this is equal to 0. Therefore, the conclusion of this one, that is dou of u comma v by dou of x comma v is equal to 0. That is nothing but it is the meaning of the functionally dependent condition. Next, now we want to find out what is the relation between the given function u and v, if it is possible that functional dependence. And clearly here verified that functional dependent the given two functions u comma v. Now we need to find out the relation between that x u comma v. While we are going to observe it in this v is equal to tan inverse x plus tan inverse y. And according to we know that the inverse trigonometric property, that is a tan inverse x plus tan inverse y is equal to that is a tan inverse of x plus y by 1 minus xy. Therefore, it is clearly tan inverse of here x is equal to x and y is equal to y. Therefore, x plus y by 1 minus xy. And here, once again, if we are going to observe this one, it is a tan inverse of, as we know that the given function is clearly that u is equal to that is a x plus y by 1 minus xy already given the condition. Therefore, it is a replace the tan inverse u only. Therefore, here clearly you obtain that v is equal to tan inverse u. And if it is v is equal to tan inverse u is a function, it is called as a relation between that is u and v. And otherwise, if it is required to mention that is v is equal to tan inverse u, otherwise it is clearly there is a tan v is equal to that u is also. Therefore, it is a relation between u comma v for the given function. It is v u is equal to tan v, otherwise v is equal to tan inverse u. Therefore, next second one, determine whether the following functions are functionally dependent or not. If they are functionally dependent, similarly here also we need to find out what is the relation between them. And now here also that we need to check out whether the functionally dependent or not. That means whether it is a debt is equal to 0 or debt is not equal to 0. Then we need to find out that is a Jacobian, that is a functionally dependent or not. First of all, according to this one determinant, here given functions are u is equal to e power x into sin y and v is equal to e power x into cos y. From that u comma v, first of all we need to find out what is dou u by dou x and dou u by dou y and dou u by dou x and dou u by dou y. Therefore, here from the u is equal to that e power x into sin y, that is dou u by dou x is equal to e power x into sin y, that is ux only, because of sin y is treated as a constant. And uy is also clearly that is e power x into cos y, because the derivative of sin y is equal to that is a cos y. And similarly from the v, then we need to find out what is dou v by dou x. Therefore, from the v is equal to that is e power x into cos y, that is dou v by dou x is also e power x into cos y, because cos y is a constant. And dou v by dou y is nothing but that is e power x is a constant, that cos y derivative is a minus sin y. Therefore, it is clearly e power x into sin y is the value. And now here also that we need to find out what is the data of this 2 by 2. And again here also the data of 2 by 2 is nothing but AD minus BC. And after that cross multiplication like AD minus BC, here a power x is a constant. You take out common outside. The remaining term is a minus sin square y minus cos square y. Therefore, it is clearly that negative take out common. That is a sin square x plus cos square x. That is sin square y plus cos square y. With the help of the formula, it is 1 only. Therefore, in this equation, it is a minus 1 into that is e power of x only. That means minus into e power x only. The conclusion of this problem, it is a minus e power x only. That means here the dt is not equal to 0. And according to this problem, the given function is not equal to dt is 0. That means the function is not a functionally dependent. Whenever this value is equal to 0, it is called as functionally dependent. But according to this one, it is a problem is a functionally independent condition. Therefore, at the time of this one, it is not possible to consider the relation between u and v. Next, coming to point, there is a second one. It is also that u is equal to x by y, and when v is equal to that is x plus y x minus y. Once again, we need to go for with the help of the derivative with respect to dependent and independent variable. Therefore, u is equal to that is dou by x and dou by y, and v is also the dou by x and dou by y. And according to this one, that is a value is a 1 by y minus x by y square minus 2y by x minus y square 2x by x minus y square. And again here also the AD minus BC. Therefore, here clearly satisfied the 2x by y into x minus y square minus 2x by y into x minus y square. Therefore, conclusion of this one, it is both of the cancel that is equal to clearly satisfied that the value is 0 only. And if it is a value is 0, that is nothing but according to the definition of the function dependent and independent, it is a function dependent only because of the data is equal to 0. And now we need to write if it is possible what is the relation between there is u comma v only. Therefore, while we are going to consider v is equal to there is x plus y by x minus y. In this, while we are going to take out y, you say the remaining term is x by y plus 1 by y into there is x by y plus 1. And once again, that y we cancel that x by y plus 1 by x by y plus 1. And again here, that one of the parties that is considered u plus 1 by that is u minus y. Because given the function is already, since there is a given condition is u is equal to x by y. Therefore, with the help of this is u, that is value is v is equal to u plus 1 by that is u minus 1 only. Therefore, this is the functional relation between u and y. Whereas the first part is a functional independent and this is the functional dependent. Because of the first one, which is data is not equal to 0, but it is data is equal to 0. But whereas that independent, there is a relation is not possible and it is a functionally dependent and the relation is possible. So next one, it is to show that the relation between also to show that the function that is u is equal to xy plus yz plus zx, v is equal to x square plus y square plus z square, and w is equal to x plus y plus z are functionally related. Then we find the relation between them. And here also, first of all, we need to verify whether the data is equal to 0 or not. That is the meaning of that is a functionally dependent or not. Here, the given problem is a 3 dependent and 3 independent. Therefore, the formation of the matrix is required to satisfy that is a 3 by 3. Therefore, the 3 by 3 we need to find. One is with respect to the u, v, w is a dependent. The independent variables are clearly x, y, z. Therefore, according to the Jacobian the definition, it is a dou of u become w by dou of x become z is equal to that is first one is dou by x, dou by y, dou by z, and with the help of the second one that is dou by x, dou by y, dou by z, and third one that is dou w by x, dou w by y, dou w by z. And with the help of that individually after that calculating with the help of the dependent variable u comma v comma w, that corresponding that matrix is the determinant of that is y plus a, z plus x, x plus y. The second row is corresponding like 2x, 2y, 2z. And last value is that is row is 1, 1, 1. And while we are going to observe in this equation, the middle of the row is common that is 2 only. Therefore, need to take out common 2 only. The remaining part is y plus z, z plus x, x plus y. The second row is x, y, z. The third row is clearly 1. And again, while we are going to observe this one, clearly the determinant of the condition, it is clearly the data is equal to 0. Otherwise, by using the condition of, by using the properties of the matrices, that is the determinant properties, then the data is equal to 0. Therefore, conclusion, here this given problem that is dependent, that is u comma v w z u v w. The independent variables are x comma y comma z. There is a three dependent, three independent. Together it is a functionally dependent condition. And again, if it is a dependent condition, therefore hence it is possible to write in the form of the relation between the them. Therefore, while we are going to consider according to the relation between, it is a therefore it is a w square is going to consider that is x plus y plus z whole square is equal to, you know that according to a plus b plus c whole square, the formula by using that one here, that is a square plus b square plus c square plus 2 into that is ab plus bc plus ca. But here with the help of the formula, it is a is equal to x, b is equal to y, and c is equal to z. Therefore, it is a w square is equal to x plus y plus z whole square is equal to, it is clearly x square plus y square plus z square plus 2 into that is xy plus yz plus zx. Therefore, with the help of the given condition of this problem, it is clearly by observing first is the condition is v plus 2 into u is a value. Because of the given values of v is equal to x square plus y square plus z square, and u is equal to the value is xy plus yz plus zx. Therefore, with the help of this conclusion, the relation between the u comma v comma w is equal to, clearly we obtain that is a w square is equal to v plus 2u is the condition. Therefore, it is a relation between the u comma v comma w with the help of the given function. Here, the conclusion of this one, it is also the possibilities, the relation between whenever the given function is a functionally dependent condition. If it is independent, it is not possible to consider right in the form of the relation between the u v w condition. Next one, verify if u is equal to that is 2x minus y plus 3z, and v is equal to that is 2x minus y minus z, and w is equal to 2x minus y plus z are functionally dependent, and if so, find the relation between them here also. Therefore, here also that according to the functionally dependent, first of all, we need to check out what is the data of this matrix, whether it is a is equal to 0, the function is dependent, whether it is not equal to 0, the function is a independent condition. And here also the given problem is the u comma v comma w are dependent, and with respect to the independent variables are x comma y comma z. Therefore, the three dependent is given. Therefore, the formation of the data is also required to find out that is a 3 by 3 data. Therefore, the dependent variables are u v w. Therefore, we need to find out what is a dou v by dou x, dou v by dou y, dou v by dou z. And similarly, the second dependent is also dou v by dou x, dou v by dou y, dou v by dou z. The third variable is also that is a dependent is a w. Therefore, we need to find out that is a dou w by dou x, dou w by dou y, dou w by dou z. While we are going to calculate it with the help of the u comma v comma w, it is clearly obtained that 1 by 1 is rows is 2 minus 1 3, 2 minus 1 minus 1, 2 minus 1 1 is a value. By using the properties of the determinant, otherwise by using the something directly, the determinant is 3 by 3. Here it is also the determinant value is clearly 0. Therefore, here according to the det is equal to 0, by the definition of the Jacobian or definition of the properties of the functionally dependent, it is clearly satisfied. That is the meaning of whenever the determinant the value is equal to 0, hence the functions are clearly that is a functionally dependent. And here, if it is a functionally dependent, therefore here it is possible to write the relation between the given dependent variable, that is u comma v comma w. While we are going to observing the given dependent variables are by adding the u plus v and also minus 2w, then according to by using this relation, it is clearly 2x minus y plus 3z plus 2x minus y minus z minus 2 into 2x minus y 9 plus z is a value. Therefore, by addition of and again that including the subtraction, the final solution is clearly 0. Therefore, hence it is a relation is clearly by using the given dependent variable with the help of the independent variables, it is obtained that is u plus v minus 2w is equal to 0. Otherwise, it is equation we can write in the form of that is u plus v is equal to 2w is also the condition. Therefore, it is clearly we obtain the relation between the u v w, it is u plus v is equal to 2w is a value. Next, show that the relation between here also, that the function that is u is equal to x plus y plus z, and v is equal to x square plus y square plus z square minus 2xy minus 2yz minus 2zx, and also the w is equal to x cube plus y cube plus z cube minus 3xyz are the functionally related. That means here also we need to find out what is the meaning of the data of the given matrix. That means here the given matrix, here the given functions are the three dependent with respect to three independent variables. Therefore, here also we need to check out whether the 3 by 3 data is equal to 0 or not. If it is 0, that is functionally dependent. If it is not equal to 0, that is functionally independent. If it is data dependent, that means data is equal to 0, then only we obtain that is a relation. If it is a linearly independent, that means that it is not equal to 0, the relation it is not exist. And once we need to check out with the help of the dependent and independent with the help of u comma v comma w. Therefore, that is dou v by x, dou v by dou y, dou v by dou z, dou v by x, dou v by dou y, dou v by dou z, and dou w by x, dou w by dou w by dou z. With the help of that clearly, we obtain that matrices obtained. That is a final conclusion of by using the determinant and also by the property of the matrices. That is a determinant of the matrices. We obtain that clearly the value is equal to 0. Therefore, it is conclusion of this one. The function is clearly, we can say that is a functionally dependent. And functionally dependent is nothing but it is a determinant is equal to 0. Now, we need to find out what is the relation between the condition with the help of the u comma v comma w. Now, here, similarly, prove that u is equal to that is x square minus y square by x square plus y square, and v is equal to that is 2xy by x square plus y square are functionally dependent, and find the relation between them. And here also the given functions are the dependent variables are 2, the independent variables are also 2. That means here we need to find out what is the data of the given matrix. Whether it is a data is equal to 0, then it is a dependent. If it is not equal to 0, it is not a independent. Therefore, here the given functions are the dependent variables are 2. Therefore, the formation of the dependent is a, we need to find the 2 by 2 is a matrix. Therefore, with the help of the dependent is u comma v. Therefore, we need to find out what is the dou v by x and dou v by dou y. And similarly, there is a dou v by x and also dou v by dou y. And here, totally the problems are u comma v is involving that x comma v in the numerator part and also the denominator part. Therefore, first of all, from the given function u, we need to find out what is the dou v by x and dou v by dou y with the help of the u by v formula. Therefore, while we are going to calculating that is a dou v by dou x is equal to the denominator into the numerator derivative minus numerator into the denominator derivative by the denominator whole square. By using this formula, therefore you obtain that clearly that dou v by dou x is equal to that is 4xy square by that is x square plus y square whole square. This is while we are going to applying that partial derivative with respect to x only. That means treated y as a constant. And similarly, while we are going to do that with respect to y, that is a dou v by dou y treated as something x is a constant. Here it is also, which is involving the numerator as well as the denominator. Therefore, the denominator into numerator derivative means numerator into the denominator derivative by the denominator whole square. And after this simplification here also, you obtain that minus 4y is x minus 4y into x square by that is x square plus y square whole square. And similarly, now we need to calculate what is dou v by dou x and dou v by dou y. And similarly, here also if you are going to observe that v is also the independent variables are x comma y, that is involved here, it is a numerator and also denominator. Therefore, the dou v by dou x is equal to that is a numerator, that is a denominator into numerator derivative minus numerator into the denominator derivative by whole square. By using that here, once again the dou v by dou x is equal to with respect to x, that means treated y as a partial, that is a constant. Therefore, the value is a 2y into y square minus x square by that is x square plus y square whole square. And similarly, while we are going to do that finally, that is dou v by dou y is also by using the u by v formula, we obtain that clearly that is 2x into that is x square minus y square by x square plus y square whole square. That means here the dependent variables are u comma v, the independent variables are x comma y. Therefore, with the help of the dependent and independent, there is a two variable that he has already completed all the four required values. Therefore, by using that, when we are going to replace in the Jacobian, that is a dou of u comma v by dou of x comma y is equal to that is a after replacement of all these values corresponding to dou v by x and dou v by dou y, dou v by dou x and dou v by dou y. By using the 2 by 2 data value, that is 2 by 2, that is AD minus BC, that it is going to clearly the value is 0. That means here the given functions are, that means u comma v are the functionally dependent. Why? Because it is a determinant is equal to 0. And now we need to calculate what is the relation between these two conditions, that is u comma v only. While we are going to observe here, it is also with the help of the given u comma v. While we are squaring on both sides, there is a u square and v square. The addition of these two, that is u square plus v square, is equal to, clearly we obtain that RHS is equal to x square minus y square by x square plus y square whole square plus 4x square y square by, that is x square plus y square whole square. Then addition of these two, then you obtain that clearly the values of 1 because of the numerator and denominator cancel. Therefore, the relation of this is the u comma v with the help of the given function. It is clearly u square plus v square is equal to 1 is the condition. Next one, show that the functionally dependent and hence find the relation between the condition. And here also we need to find out whether the determinant is equal to 0 or not equal to 0. First we need to check out the condition. That means here this problem is given that u comma v comma w is 3 dependent and with respect to independent variables x comma y comma z. Therefore, that is we need to check out what is the determinant of the 3 by 3 is a condition. Therefore, with the help of the dependent suitable, we need to find out what is the dou by x, dou by z, and dou by x, dou by y, dou by z, and dou by x, dou by y, dou by z. And with the help of the given function, when you are dividing 1 by 1, that is a dou by x, again it is nothing but e power y into sine z only, because of we derivative with respect to x as a partial only. And similarly, 1 by 1, if you are going to do that, that is a v square dou u by dou y is also x in d power y into sin z. Dou u by dou z is also x in d power of y into cos z. And similarly, dou u by dou x with the help of v is equal to, that is e power y into cos z. And dou u by dou y is also x in d power y into cos z. And dou u by dou z is also with the help of that z is equal to, that v is equal to minus x in d power y into sin of z. And with the help of the w is also dou w by dou x 2x square into e power 2y. Dou w by dou y also 2x square into e power 2y. Dou w by dou z is also the value is 0. Then with the help of this the 3 by 3 determinant condition, here clearly you obtain the value that is equal to 0. Therefore, here conclusion of this one, it is a determinant the value, that is a Jacobian value, it is a determinant is a 0. That is a meaning of u comma v comma w are functionally dependent. And if it is a functionally dependent, the given function is nothing but it is possible to write the relation between u comma v comma w. Therefore, it is according to the u square plus v square while you are going to squaring and addition. Therefore, you obtain that there is x square into e power of 2y into sin square z plus x square into e power 2y into cos square z. Then once again you need to take out from x square into e power 2y is outside. The remaining part is a sin square z plus cos square z. We know that the sin square z plus cos square z is the value is 1 only. Therefore, with the help of here, that is as x square into e power 2y only. Therefore, that u square plus v square is equal to the value is w. Therefore, this is the relation between the u comma v comma w. It is a possibility that is u square plus v square is equal to w. Why? Because it is a given functions are clearly functionally dependent. Next here, show that the functions that is dependent, hence find the relation between them also. Therefore, here also, according to the given function, it is a 3 dependent variable, that is a u, v, w. Therefore, the determinant we need to check out. If it is a that is equal to 0, then it is a functional dependent, that it is not equal to 0, the functionally independent. Therefore, it is a dependent variable with respect to independent variable sum, that is dou of u comma v comma w by dou of x comma v comma z. By using the Jacobian, we need to calculate that is dou by dou x, dou by dou y, dou by dou z, dou by dou x, dou by dou y, dou by dou z, dou w by dou x, dou w by dou y, dou w by dou z. We need to calculate. Here automatically the values is going to clearly satisfy the 0. Therefore, the function will dependent. Now we need to find out what is the relation between the given condition. While we are going to observing in the given equation, that is the third one, that is a w dependent variable. While we are squaring the w square, the right side is clearly that is x plus y plus z whole square. Therefore, the x plus y plus z whole square is you can consider according to formula a plus b plus c whole square is nothing but a square plus b square plus c square plus 2 into that is ab plus bc plus a is a condition. But here a is equal to x, b is equal to y, c is equal to z. Therefore, with the help of that one, it is x plus y plus z whole square is equal to that is x square plus y square plus z square plus 2 into xy plus yz plus zx is the value. Therefore, it is clearly the conclusion that is a w square is equal to that is a b plus 2u is the relation between the u comma v comma w. Because of here the function, the given dependent variables are functionally dependent, then only it is existed. For example, in this problem, the function determinant is not equal to 0, hence it is a relation is not possible. Next one, show that u is equal to x cube minus y cube into z cube, and v is equal to x square plus y square into z square plus x y z, and also w is equal to x minus y z are functionally dependent, and find the relation between. And here also, according to the concept, we need to find out whether the determinant is a 0 or not. If it is a determinant 0, then the function is a dependent. And here also, that u comma v comma w are the three dependent variables. Therefore, we need to find out what is the 3 by 3 details value. Therefore, it is a dependent variables are u v w. Again, here also you need to find out that is a dou u by dou x, dou u by dou y, dou u by dou z, dou v by dou x, dou v by dou y, dou v by dou z. Therefore, with the help of the given functions u comma v comma w, here the corresponding values are 1 by 1, that is a 3x square minus 3y square into z cube minus 3y cube into z cube. And similarly, the second row is also with the help of the v, that is a v 2x plus yz, 2yz square plus xz, 2y square z plus xy. And the third row is with the help of the w, that is a 1 minus z minus y, by using the properties of the matrices determinant, otherwise by using the determinant value, that clearly the relation is a 0. Hence, if it is a determinant is equal to 0, automatically the given functions are said to be, that is functionally dependent. Then, here according to here the determinant is a 0, therefore the functions are said to be functionally dependent. And again, here if it is a determinant is 0, then automatically which is satisfied the relationship between them also. And while we are going to observe here, that is u, that means it is considered that is x cube minus y cube into z cube is equal to clearly satisfied v into z also. That v is equal to x minus yz, and w is also nothing but x square plus xyz plus y square into z square. That is the meaning of here. With the help of the given function, it is a relation between that clearly satisfied that u is equal to v into w. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.